Hey, what's up everybody? We're going to take a quick look at problems number 10 and 11. Very similar to problem number 9, except we are given a molecular equation and we're asked to write the net ionic equation. I'm going to do that first because the spectator ions are actually not taking part in the chemistry. Those things are not going to undergo a change in oxidation number or oxidation state. So it'll make my life easier if I can just get them out of the way. Okay, so as I think back to the good old days of Unit 10 and writing net ionic equations, remember anything that is aqueous, you want to split up into its individual ions. In this case, copper 2 ions and sulfate ions. We'll do the same thing on the product side. Boom, I now have a total or complete ionic equation. My only spectator here is the sulfate ion. Now, you don't necessarily have to write out the complete ionic equation. If you are chemistry savvy enough and can figure that out without the complete ionic equation, power to you. So my net ionic equation is going to look something like this. Let's assign some oxidation numbers, 0, 0 for our neutral elements, +2, +2 for our monatomic ions. As I think then about what has been oxidized, it is going to be our zinc that has lost electrons. The oxidation half reaction, remember, is going to include the electrons on the product side. This one's a little easier than the last one because my coefficients are 1. So my zinc is going to lose 2 electrons or 2 moles of electrons for every 1 mole of zinc. What has been reduced, you ask? It's our copper ion. It goes from the +2 to 0 oxidation state. Our reduction half reaction, we're going to have the electrons on the reactant side, again, fairly easy because the ratios here are 1 to 1, so it's just going to be gaining 2 electrons or 2 moles of electrons for every 1 mole of copper 2 ions. Boom, and we are done.